Welcome to my talk. My name is John Lavin, and I'm an enterprise architect at the Vanguard group. And I'm one of the people there responsible for helping migrate our monolithic software and to services and ultimately to the cloud. So I wanted to share with you some of the tools that we're in the midst of developing that we use to manage both our Java modules as well as our services and microservices. So I'm going to talk about the state of the systems and the problems that we faced, and then we'll review the data that I'm storing, or we're storing in Neo4j, and how we're making use of that. And lastly, I'll talk about some of the future plans that we have in store to enhance our tools. So there should be some time for questions at the end as well. So first, a little bit about the Vanguard group. Based in Malvern, Pennsylvania, we are the largest provider of mutual funds. We're a financial services company. Our founder, John Bogle, was the actual creator of index funds, and that's still a major primary focus with us at Vanguard. I personally am in the institutional subdivision of IT, managing the business of your 401ks. So you might have a 401k with us if your company is using us to save for retirement. In addition to that, we have many other departments. We're the second largest ETF company, second behind BlackRock, but we're closing. And that'll be enough for the infomercial. Let's get into it. So I say managing code is critical, and that might sound like a pretty obvious thing to say, but when I have conversations with other people in other companies and in our company, the focus really is more on feature delivery and the time to market of getting things out the door. So what I've found and what we found is that if you don't make it easy to manage code, then it just doesn't get done. So it's not unusual for some of our oldest jars to have 3 to 4 million lines of code, literally. We have multiple design patterns used over 10 to 15 years. We've been around for a little while. And those design patterns, we'd be lucky to have some design patterns. Sometimes we don't have any design patterns at all. We have dead code, and we have some difficult or incomplete, difficult to accomplish or incomplete impact assessments to be made. If you're familiar with code smells, you're probably familiar with the shotgun surgery anti-pattern. So we have these difficulties in our modules in the past, and we wanted to easily manage our Java modules and prevent our new code that we're writing to have these same problems. So our first answer was to use a third-party product called Structure 101. I don't know if anybody's familiar with it, but it is a tool that you can load your jar files in to memory on your desktop. You can visualize and depict, almost like a graph, your dependencies and all the relationship between the jars. The problem, however, we found quickly with using Structure 101 was that it's good if you know all the dependencies and the jars that you're relying on, or you can't import them in and load them and see them in the visualization. So we have a lot of different subdivisions in our IT department, and the development team that's using that jar file, or that's building the jar file, quite often it'll be reused without that knowledge. So it'd be very difficult to find all the interactions if you can't even load it into the tool. The second thing is with our existing codes, when we start building out our services and we try to disentangle our monolithic software, we had so many jars in the libraries in the monolith that were deployed that it would actually crash Structure 101, could not take the visualizations. So there were two problems that we had. The last problem is that if we knew what the jar dependencies were, we knew who was using it, and it's still loaded in memory, it was still a highly manual process where we had to have some developer load up the jars, bring it into the tool on their desktop, and then act on it. So these were problems that really that tool wasn't equipped to handle. So now We're moving from our large monolithic services or monolithic applications to adding microservices and having to deal with services and deployments on top of that. And this is the old libraries and the business logic doesn't go away. We're adding this extra complexity on top of our existing software. So to tackle this, we started in the beginning with managing our services by a spreadsheet. And doesn't everything really start with a spreadsheet? It was written over the course of a year where we actually tried to inventory the services that we'd build if we were given an infinite amount of time and an infinite amount of resources. However, we don't have an infinite amount of time and we don't have an infinite amount of resources. So what ended up happening is that if the business logic hadn't changed, we're just building a service off of it, usually what we would take is the existing software and we would deploy it as its own service. We also had cases where we just wanted to put a new user interface on top of the software and we wanted to just provide a REST endpoint to deliver a new UI and just leave the existing software and business logic that just works alone. However, what that meant is that we had a lot of different services in a lot of different states, and we were all tracking it in a spreadsheet. And this input of this metadata, the services, we tried to group things and document the dependencies as best as we could in a spreadsheet, but it really just wasn't going to work out long term. There are other questions that were never answered by a spreadsheet or some other tool. The basic functions were captured, but there were large gaps. We didn't know where our service was deployed. We didn't know what services were being called by other services. We didn't know what jars and business logic was being used by the services. And we had no idea of how we would categorize whether a service is healthy or whether it had a lot of technical debt that we might need to fix later on. So we needed something better. So ultimately, that's when we learned about Neo4j. And this was our first foray into using graph databases and learning about it. And we realized that the management of our modules and services really was a graph problem. Okay. So we started out very, very simply. And we just had a simple node and one dependency, or one relationship to that node. So we stored our jar dependencies, the group name and version. And what we did here is to automate this, at Vanguard, we still use Maven for our builds. And we wrote a Maven plugin to run every single time we do a build to gather this information and send it over to Neo4j. So as we built out new artifacts and new products, we were actually just sending the data for the jars and its dependencies on other modules along to Neo4j. Later on, after we got successful with gathering the data on our ongoing builds, we went back to our artifact repository, Nexus, and then ran an automation job to actually get the jar data, module data for previously built artifacts and load that also into Neo4j. So what that did is that provided us a wealth of information about a simple jar and dependency graph. And the information that we wanted to get out of it and understand our jars is something that we got from Robert C. Martin. So people familiar with Uncle Bob, hopefully. Uncle Bob wrote a book back in 2003 called Agile Software Development, Agile Software Development, Principles, Patterns, and Practices. In chapter 20, there's an important section on Java package design. And Uncle Bob was referring to the partitioning of Java packages within a Java module, but we believe that the principles that he espoused for Java packages go for the Java libraries themselves. So in our graph, we implemented acyclic dependency principles. So we fail our build if we have any module cycles, no matter how deep we go. So we have, if we have different subdivisions using the same jars, quite often we would find that they come around and start depending on each other. So we wanted to avoid that and fail the builds immediately on that to enforce good, healthy jars. A couple of other metrics we have: afferent coupling, which is the incoming dependencies to a jar, the efferent coupling, which is the outgoing dependencies of a jar, and then the instability is a metric of the outgoing divided by the sum total of both the incoming and outgoing. So you can decide, you can understand the relationship of the Java library based on these metrics. One other metric that came into play through a book called Java Application Architecture that was written by Kurt Knaerschild is called levelized modules. So the idea here is that they want to understand where the relationships of different modules are in relationship to your entire stack of Java modules. So he came up with these different levels where if a jar that you're developing only depends on external libraries outside of your company, it will be a level level 1. External modules are level 0. Your modules that depend only on level 0 or level 1. And level 2 modules are only dependent on level 0 or level 1, and so forth. So this is a little bit more fine-grained than if you have different layers in your architecture. If you have an entity layer, a data access layer, and so forth, you can have many different levels within a layer. So that gave us some insights on exactly how our modules and architecture are laid out. Once we moved past getting the data for particular jar libraries in, we then took on the incorporation of bringing in the data from our spreadsheet, where we were managing our services out of a spreadsheet, and began to model that in our Neo4j database. So at the top here, we have a concept of our artifacts. In particular, right now, services are within groupings that we want to logically define. And we can have different metadata tagged, such as a good example here would be whether it's in the public cloud or it's on my on-prem database. So we have the ability to dynamically tag any of our artifacts, again, mostly services right now. And we have many different attributes that we want to assign to these things. And we pulled that from the spreadsheet over here. And any artifact is built an instance. So every single time we build our web services, we will create an instance here through, again, a Maven plugin that is running on the services. And we will record the new instance that was just built and record the jar dependencies that they are using. So this ties in with our pre-existing jar libraries, and we can associate our services all the way down through our jars. We have a little bit more in the model, but for clarity purposes, I'm leaving it at this level. And again, any service can call another service, so we have the uses relationship on the artifact there. Okay. All right, so on top of this data, we created 2 tools. So we gathered this data, we're using Maven plugin, and we created 2 sets of tools. The first one we named Modularity Assessment Tool Suite, or MATS. And that one, those tools were primarily designed to manage our jar files. The second one, the Enterprise Service Catalog, we codenamed Excelsior, was for the management of our what used to be a spreadsheet and now is stored in Neo4j. Okay. So these tools utilize, first we have a Maven plugin for each. And for the Modular Assessment Tool Suite, we also have a Sonar plugin. So if you don't know what Sonar is, it is a code quality analysis tool that provides your code coverage numbers, your code smells, all of your nitty-gritty static analysis. And this is really where our tools are playing in static analysis. So what we did was Sonar Cube is extensible. So we designed a plugin so that we could represent the data that we were storing in Neo4j in Sonar. And I'll have an example or a screenshot of that a little later. Another thing we designed for the modularity assessment tool suite is we have some D3 and Angular visualizations, of which I'll show you. I have examples of later on. For Service Catalog, we have another Maven plugin. Our catalog is completely Angular based, and we plan to also integrate our UI, our Angular UI JavaScript modules in. So we have a planned Grunt plugin. And we have some D3 visualizations modeled off our modularity assessment tool suite visualizations planned as well. All right. So real quick, I wanted to give you an example. I put together a small graph with just some example information of how the data might look. So in this case, from your left to right, I have a single artifact, which is an account service, and it built a 1.0 and a 2.0 version. And the green nodes are jar modules. So since this is such a small graph, you can see that I did introduce a cycle in version 2 in this graph. So this is an example of the data, the sort of data we're looking to store. So our afferent coupling and incoming dependencies are just a simple query here. And this gives us our incoming dependencies on our group artifact and version. So I can see how many incoming dependencies. And reverse the query. Now I have the outgoing dependencies. Okay. So something that was manual in a third-party tool and I had to load it in memory now becomes an extremely simple Cypher query. And then one last Cypher query before I go to the screenshots of the examples of the tool are, here's a query that just gets me that cycle that we saw on the previous slide. So with this information, just these simple metrics and a little bit of math, you can get a lot of these module metrics through simple Cypher queries. Okay. So here I'm going to show you a couple of our visualizations or metrics that we use. And this first one is a screenshot of our Sonar plugin. So what this is used for is when a developer is looking at their source code, they have their code coverage and all their code quality metrics when they go to Sonar Cube. And we designed this plugin to set alongside with all the other metrics about that particular Java project. So this was not only good for our development teams to see where they are, where their code health is, but we found it essential for management to engage our management team in understanding not only are you delivering on time, but what are you delivering is quality or not. And how we came up with our assessment of quality is we came up with this concept of a grade. So a lot of these metrics, and I'd love to talk about these metrics much more. Get me off to the side. I have plenty to talk about, but a lot of them don't roll up. So a lot of, from a management perspective, a single project isn't as useful as if they look at entire aggregation of whether or not it's all of a monolith or all of a product ownership, or all of a number of different jars that a particular manager owns. So what we did was we created a grade. And based on the type of module it is, we can assess a red, green, yellow to that particular score, that metric. And once we assign a grade overall to the module, then we can roll up our grades to give an aggregate grade for a different collection of many different modules. So this is really helpful for engaging our management into why this is helpful and how it's trending as well, whether we're getting better or worse. So this example, this screenshot is from the Enterprise Service Catalog. And this service catalog, along with the dashboard up at the top, was a simple visualization of managers love spreadsheets, so we came up with the visualization of our graph data to be more in spreadsheet form. So I have a couple of dummy examples of services here that list out the information or list out the services that we have available. And what we did in the, we gave a lot of different ways to filter on the data. So you can do a full text search on all the services at the top. But they also have a pull down so that you can select services that are in production, are in public cloud, have certain types of technical debt. If you're tagging your services with technical debt or jars with technical debt, you can do queries based on those filters and then shorten your list and render them out. Here's a picture, if you clicked on any of the services, a detailed list. The information, the metadata that we have provided is in groupings on the left, on those left tabs, and I've selected the jar dependencies. So if you select a service and you want the jar dependencies, you select the version. I only have the 1.0 snapshot there, but you select the version and then we'll query Neo4j and get all of the direct dependencies that service has. And then if I were to collapse this, also the transitive dependencies come in. So I do a full depth search on all the artifact dependencies, no matter how deep they go. So now we moved out to D3 visualizations, and what we wanted to do here was depict our modules and service dependencies in a way where we can understand the depth and the fan out of how our dependencies for our services and modules are moving throughout our architecture. So in this case, we have on the left-hand side, I have an example of a Vanguard module and all of its dependencies. And in this case, we're 4 layers deep with our dependencies that I've expanded out. So I wanted to stop here and just call out, if it wasn't clear already, I wanted to make sure that you're aware that unlike some tools, such as like an API gateway that's looking at your runtime mapping of your services and your interactions, what we're doing through collecting this data and storing it in Neo4j at build time, we're doing this static analysis. We're doing it statically and looking at the actual code for all the code paths or the dependencies that are declared there. So what that means when we come to services is that, at least for our company and our financial services industry, we have services that are only called during certain times of the year. Statements called maybe every month or every quarter or every year end. Tax forms, April's a big time for us. So a lot of the call graph won't necessarily be populated by anything that's looking at the active runtime service calls, such as an API gateway would get you. So for us to do a complete impact assessment, we really wanted to be able to, when we're making changes, to have a complete look by using static analysis. Okay. So those one-off calls will get swept in if you're looking at the code. They will not be visible in an API gateway. Okay. So this is great not only for impact assessment, but it's also important for our production support. So if we're having an outage or we're having errors on a particular service or we're seeing it in certain number of services, we can query on those services and see where it's going to fan out, because if one service is dependent on another, we can see where a trouble in one service is going to go in other places in our site. We can see cascading failures and we can kind of trace back to particular services that may be in common. So another thing that we want to take a hard look at, this is in our future plans, I'll speak to it now, is we want to look at the levels. We want to contain the number of service-to-service calls we make. We don't want to see, if these were modules instead of services, we don't want to have a service A calling, how many is that? 15 different other services to render its data. And if that service A at the very front is a critical system that we can't have down, the more services you have dependent on that, there's more likelihood that that service is not going to be available more often. So what we would like to do is design metrics around this to count the number of services that a particular service is dependent on, so just a strict count, and maybe put a hard limit on how many services. That if you have too many services being called, that probably means you got your bounded context wrong in your services. The other thing is that we want to see what the call depth is as well. So we might measure the call depth in the future, where I don't want to go any deeper than 2 service calls deep or 3 service calls deep. Because the more, if they're serial calls to service to service to service, there's more likelihood that any one of those could kill your entire service. So we're investigating ways to see how, or what would be the appropriate metrics around how we would identify problem areas before we actually have an outage in production. Okay. All right. So the next visualization, and after I looked at some of the vendors, I'm like, it steals a little of my thunder looking at some of what the vendors provide. But the visualization we have here is of our modules and the dependencies that those modules have. So this is, I guess you could, it might not necessarily look that far cry away from the base Neo4j depiction, but we added some bells and whistles that we found very helpful. And the first one here is that we have, we can size the dots based on the scale of incoming or outgoing dependencies or their instability or any other metric. So the larger dots there have, I think, which one did I put on there? So the larger the dot in this screenshot is the larger number of outgoing dependencies. So you can actually see where we're having a little centrality. This is kind of like a poor man's centrality, I guess, where we can actually see exactly where these modules are playing key roles in other modules. The other thing we allow up on the top right here is that if I was to depict one of our large monolithic applications with all the jars that it has dependent on it, I would have a really hard time finding any particular node in there and seeing it. So we have a full text-based search that you can actually search on any module that's in the graph, and it'll highlight for us in our depiction. The next thing that we want to do is we have multiple different ways to filter. So we may or may not, we're recording external dependencies such as like Spring libraries and other Apache libraries, for example. And since we don't have any control over those, we might not want to visualize that. We have a radio button, we can turn them off and remove it from a visualization. The other thing we can do on the right-hand side, we have the legend that shows the colors of the different groupings of the modules. Not only does it show colors, but that checkbox will allow us to remove different types of modules from the visualization immediately. So we can just focus on particular groupings of modules that are important for our particular situation now. So I wanted to talk a little bit about our future plans now. So we have a Sonar plugin for our module metrics. We do not have a Sonar plugin yet for our services. So we also want to be able to look up our web service in our source control Sonar Cube system and be able to see the metrics for our service right there along. So this is, again, is to engage our management team into being able to see these metrics, put them up in the forefront of their minds when they're developing their services. And that seems to be the best way. Whenever we talk to managers, they go right to the Sonar dashboards and they look at that numbers and they see whether it's trending up or down, and then they make a phone call to their project manager and tech lead and say, hey, why is my numbers going down? My boss is going to tell me about it. So it is a really great way of pulling these numbers and metrics up and keeping your code clean just because you're all looking at it. We'll have afferent and efferent coupling. I also talked earlier about the fact that we're going to look at service level depth, service call depth, and the total number of services. So there's some other metrics that we're looking on capturing and rendering on our Sonar dashboard. The other thing we're looking to do right now, we're primarily automating our services. We have manually put in our UIs, but we want to develop a Grunt plugin and automate gathering our user interfaces. So for Vanguard, we're migrating to an AngularJS client-side architecture, and we want to be able to identify in those JavaScript projects what services those user interfaces are calling. So we want to be able to build a Grunt plugin, gather that data, store it in Neo4j. And then the other thing that we want to do on the back-end side is that for our data management and governance, we also want to pull that in. And we also wanted to use static analysis. For this, we're using bcell to gather our data access routine. So if we're using a database, we're calling tables and columns. We're still mostly a relational database shop. So we want to gather the tables, columns, store procedures that we call. And we also want to attach it with a jar file and associate that store procedure or those tables with that jar file that's using those. So what that allows us to do at the end, once we get our UIs and all the way down to our stored procedures, is that we get an end-to-end look at where our data, our critical data, our sensitive data, in the era of hacks and data places like Equifax, we want to know exactly where our data is being used, where it's exposed, and be able to identify any areas where, hey, why are you deploying this social security number over to this UI? Why are you exposing this personal credentials information, and ask these questions? We have a process to manage our data, but some of the steps are manual, and what we're looking to use Neo4j to do is automate those steps so that we have a much more accurate and complete picture of how our data is being used and where it is being exposed throughout our sites, plural. And the last item that we want to do is that I mentioned very beginning in the beginning of the presentation, we have a lot of dead code or libraries that are 10, 15 years old, big, difficult to manage jar files. We want to eliminate those slowly. And as I mentioned, we don't have infinite time, we don't have infinite resources and money. So we want to be able to take our services and jars and identify where potentially deprecated libraries, services that are using deprecated libraries are being used, and say, hey, while you're in this service, let's go get rid of this dead code. Let's get rid of this old logic that we've been looking to retire, this difficult to manage code, and be able to identify those at a glance with a simple Cypher query. The last thing we're doing as far as engaging all this data and continue to roll it out is that we're using our service catalog for not only just looking at what is, but what we want to be. So I talked about the spreadsheet being also planning data. So when a project team goes into their planning sprint and their early working sprints, we actually use this tool, this is one of our primary use cases, to identify which services that we want to be using. So we want to provide additional information as far as where those services are being used, what's partially built out, and where they can add their logic that makes sense in our overall architectural scheme. And with that, I did save time for questions. Thank you. Yep. And it's a little tough to hear, so I'm going to.
At the start, you mentioned that you started with a small schema and then you kind of expanded out.
Mm-hmm.
Okay, my question is, every time you expanded, did you have to kind of drop the data and put the data back up again, reload the data, if you will, or
Okay.
did you just expand it?
Okay. So the question was is that as our team moved from our small schema, which was our simple jar node and one relationship, and we moved to our larger schema, did we have to do a transformation, a drop, and a restart of our data? So we didn't, because we had because we do not enforce a lot of schema on the Neo4j database. So we didn't have, all we simply did was have a new tool that created new endpoints, and we just added new Cypher queries. So we just kept adding. And I think that's one of the real benefits of Neo4j, which is that you can have a schemaless data model, and that as you change the data model, you can just keep adding new information to it. The biggest problem you'll have with doing that is that if you make a mistake in your code, and you don't model, or you're not inputting your data the way that you wanted to model it, and then you have to do some rejiggering. But for just the strict exercise of expanding our data model to services, no, we didn't. Yeah.
When you migrate a monolith, do you like break the whole monolith up into a bunch of services, or do you like hive off a service at a time?
Okay.
You know, gradually reducing the size of the monolith?
Yep. So the question is that when we're breaking up one of our monoliths, and we have 3 major monoliths that we're in the process of chunking up. So we can't afford, there's no way we have infinite time and money to just rewrite the entire monolith. So that was definitely out. The approach that we used, we had multiple different approaches, and this is why we needed something better in a spreadsheet, is because we had to track where we were in the the motion to our proper services is that we might choose, depending on the budget and how much the business capabilities change, to just rewrite. So we would take a certain capability and when we write a new service, the exact way with the new architecture that we wanted and just rewrite it. And then we will retire the old stuff and disable the stuff in the monolith. The second one that I would mention is that the business logic wasn't changing, but we wanted to extract that logic out and make it a service. So we have some, what I wouldn't call microservices, they're just simply services, where we took significant chunks of logic that were logical components, they had a good bounded context, and we took those existing jars that were deployed in our monolith, and then deployed them separately and put REST endpoints on top of it, and then put a new UI on top of that. And then the third one that we did, which is when we don't have hardly any money, but we need a REST endpoint, we would just create a REST endpoint on top of the monolith, so at least our user experience was completely devoid of where our service was, and that if we eventually came back and said, yes, it's worth pulling out the code, the UI would not be affected. We just have to, I can't get into our acceptance testing, automated tests, but as long as our automated tests for our contract pass with our new service, then we're good to go. And we can just repoint it to our new service instead of the REST endpoint that was just like bolted onto the monolith.
In the first case, you would take the code out of and when you were finished, you take the code out of the jar, and it would call the new service.
In the first instance where we do a rewrite, we just rewrite. And there might be some Control-C, Control-V, but we want to, the reason why we're doing rewrite is because we don't want to carry forward that code in whole. Yeah, and we have the budget, we want to make a clean cut. A lot of it, like, if you look at existing code bases, they're a little too tangled, and it was like it would be more expensive to try and disentangle it than to say let's re-implement. Yes. Yes, so the second instance is that the business logic is fine, the jars are pretty self-contained, we can take that logic and then we can just deploy that as a different unit and put a new REST service on top of it. Yes?
How many data you have when you start with, like a client, number of clients, and when you add client in, is there any change in your decision?
So, are you asking how much data is in our database? And how? Okay. Okay. So how much data is in our database? So we have, at the last time when I remember doing the Nexus preload, where we actually went back and loaded all of our jars, I think we had, counting different versions and artifacts and some external libraries, I think it was around 40,000 to 50,000 different jars that we had in our Nexus repository. And then for our services, and I can only speak for my sub-department specifically, we have, actually I should have the screenshot, I think we have roughly 320 services planned. And again, our catalog contains planned services that we want to build, we aspire to build, as well as services that are pre-existing, partially built, as well as completely built. So again, all these complexities, the tags that we put on there is to understand where in the life cycle we are in our migration to fully microservices. Does that answer your question? Okay.
You mentioned that you can know which stop procedures that a service is using, and you put that into a Neo4j database.
Yes.
Are you manually doing this, or how do you automatically do this?
So the question was around identifying the stored procedures or even the tables or columns. So we do it automatically. So what we do is there's a library that you can download right now. It's called bcell. And we have specific data access patterns that are enforced in our code base that I can go and search for using the bcell bytecode inspection. Bcell inspects your bytecode, and I can look for specific keys that identify as, hey, this is a stored procedure, and the stored procedure name will be off this method, because we have an enforced standard on how the pattern is going to look. And once I find that, then I can get that data, and in my REST API call to Neo4j, I store that data, and I associate it. I just have a calls relationship, jar calls stored procedure, or jar uses table, uses column. So we can do those kind of dependencies automatically. So for our JPA or our stored procedure calls, and some of our older calls where we didn't enforce that standard, we don't have a great way to do that. But with our new code, we have a standard. It's consistent. It's almost templated, so you can always look for it and you can get it. Okay. So I'm be up here for any other questions.